Most people believe that learning happens when you consume information. Science tells a different story. When you read a book or watch a tutorial, you are creating passive recognition. Your brain recognizes the data, but it hasn't built the physical neural architecture to execute it. Without application, your brain undergoes synaptic pruning, the biological process of deleting information it deems useless to save energy. If you don't use it within 72 hours, your brain literally starts throwing the data away. To keep it, you have to prove it's a matter of survival. The secret to permanent memory is encoding. By taking a shot at a real-world problem, you trigger a state called neuroplasticity. When you struggle to solve a problem like writing code for a work ticket or fixing a household appliance, your brain releases acetylcholine and norepinephrine. These neurochemicals act like biological highlighters, marking the specific neurons involved for strengthening. This long-term potentiation is the physical thickening of neural pathways. You aren't just learning, you are physically rewiring your hardware through the stress of application. But high-velocity input is only half the equation. You don't actually acquire a skill while you're staring at the monitor. Neural connections are synthesized, pruned, and permanently written to your hardware while you sleep. If your evening transition is chaotic, your brain never enters the deep recovery states required for memory consolidation. To lock in what you studied today, you have to execute protocol LP-03, the night protocol. This is your system shutdown sequence. We start by enforcing a digital sunset, cutting off all screens at least 30 minutes before sleep. We kill the blue light to signal to the nervous system that the operational shift is over. Next, we clear the volatile RAM. When you leave your desk with unresolved bugs, open tabs, and unfinished concepts, your brain gets trapped in a background processing loop. It keeps rendering the stress all night. Grab a physical notebook. Spend 5 minutes executing a raw brain dump. Write down every open task, every line of code you need to debug tomorrow, and every concept you just learned. By mapping it to an analog medium, you tell your subconscious, this data is backed up. You are cleared to drop it. You air gap your mind, secure your sleep, and wake up ready to deploy. Traditional studying often leads to cognitive overload, jamming your working memory with too much data until it crashes. Just-in-time research works because it respects your brain's limits. By focusing on one specific friction point, you utilize chunking. You master one small chunk of information, move it to long-term storage through immediate action, and free up your mental RAM for the next task. This is the difference between a system that freezes and one that operates at peak velocity. Traditional studying often leads to cognitive overload, jamming your working memory with too much data until it crashes. Just-in-time research works because it respects your brain's limits. By focusing on one specific friction point, you utilize chunking. You master one small chunk of information, move it to long-term storage through immediate action, and free up your mental RAM for the next task. This is the difference between a system that freezes and one that operates at peak velocity. Don't forget to comment, subscribe, and like the video for the next protocol.